Welcome to our presentation of how to work network segmentation using CIDR to create smaller subnets. Here are the essential concepts. When CIDR slides the subnet mask to the right to increase the mask, meaning increase the mask with more ones, this will increase the subnet mask value and decrease the size of the network. So there are fewer network clients that can be accommodated. When CIDR is used to slide the subnet mask to the left, this decreases the value of the mask, and that decreasing subnet mask increases the size of the network. So basically, there are more network clients that can be accommodated. So we can custom fit the size of a network to decrease congestion, improve management, avoid security issues. Each place the subnet changes, it either halves or doubles the outcome. So if the subnet increases to the right, it halves the number of network clients, but increases the number of, it doubles the number of networks in an address range that can be created. When the subnet mask is slid to the left, it doubles the number of network clients that can be accommodated, but it decreases the number of effective networks you can configure. We'll show you some examples in just a minute. So when that subnet mask changes, it modifies the network ID, the gateway, along with it. And handy templates make quick work of it. You just have to remember the original client address for placement when you're using the templates. So let's take some quick examples into account. Let's look at how, if we increase subnet mask, how that changes the values along the way. So with a /24 subnet mask, we have 24 ones and 8 zeros, or a decimal value of 255.255.255.0. And that means there's just one network with 253 clients, a network ID, a gateway address, and a broadcast address. But if we use CIDR and slide to the right just one place, now we've added a 1, we have 7 zeros. That has increased the value of the subnet mask from a .0 to a .128. That's what the decimal value of 1,000,000 actually is. But now we have two networks with two network IDs and two gateways and two broadcast addresses, but they can only handle half the number of clients, 125 clients each. If we slide one more place, we've slid 2 places over from a /24. We have 6 zeros. This decimal value, 11,000,000 is actually 192. So the subnet mask value increases. But we have 4 networks. So we've doubled the number of networks from 25 to 26. But we've cut in half the number of clients that can be accommodated in each. So now we have 4 networks, network 1, network 2, network 3, network 4, in that range, whatever range we're using. We have 4 gateways, we have 4 broadcasts, but we can only accommodate 61 network clients. So let's take 2 quick examples of how this would work with the templates, just to see how that works. So here we're going to increase the value to 25, right? We want to know, how do the network IDs, gateways, broadcast values change as the sizes change? What you see here is, from the /25 template, is that the mask increased by 1. The CIDR multiple is 128 instead of 256. We have 125 possible hosts. We have 2 networks, network 1 and network 2. The first network ID starts with .0, the gateway is .1, and the broadcast is .127. We have a second network. The network ID is .128. So if we had a 192.168.0, we could have a 192.168.0.0, that's network 1, and then we could have 192.168.0.128, That's the second network. The gateway for that network is 129. The broadcast is 255. Here are the first and the last usable addresses. Let's look at a /26. The template for a /26 shows the mask increased by 2 from 24. /24, a class C address range, right? We can have 4 networks out of that. We can make 4 networks instead of just having one network with 256 addresses wasted. We can break that down and we can supply different numbers of networks now instead of just one big network. The CIDR multiple is 64. Each network has a number of possible host or client network connections, 61 of those. You'll see network 1 starts at network ID of 0, network 2 starts with 64, network 3 starts with 128, and network 4 starts with 192. The gateway numbers for each of those change accordingly, and the broadcast numbers change. First usable and last usable IP addresses in the last octet, right? The last octet value would start with a .2, so the first network client on network 1 would have a .2. In network 2, the first network client would have a .66, and so on. So let's try 2 examples. If I give you a client IP address, can you use the templates and to determine how this works? It's actually pretty easy to do. If we have a client address of 67.149.229.51 with a /24 subnet mask, and we increase the subnet by 3 to 27, the original client portion of the address is 51. The network identity comes from the first 3 octets, and the client address comes from the last octet. So we need to remember that 51 is the client address. That's important. You'll see in a minute. Using the 27 template with this client address, you'll see a /27 is a subnet mask increase of 3 from a /24. There are 8 possible networks. Each of the 8 networks has different IDs. And what we want to do is look at this client address, because when we see this client address, we want to determine which network would accommodate this client address. It turns out that network number 2, which starts, the first usable client address is 34 and the last usable client address is 62. Network 2 is our point of reference. So now we can use the first part of the network value. Don't forget those first 3 octets to complete the process. So what's our real network? What's the whole network identity? 67.149.229.32. And it's a /27 subnet mask. And that's the network ID. The gateway value would be 33. The broadcast value would be 63. You would not want to put any network clients on .63 because it's used for broadcast. ARP and all that. Okay. So let's take another example. Let's say we have a client IP address of 165.210.0.195 with a /24 address, and we want to increase the subnet by 2 to apply CIDR to segment the network, right? For network segmentation, so we can do subnetting and be precise with how we configure our networks. We have a client address of 195. That's the last octet. We're using a /26 template. With this address, /26 template is a mask increase of 2. CIDR multiple is 64. The number of possible hosts for each network that's formed. With a /26, 61 possible hosts. We want to look at 195 to see which network 1, 2, 3, or 4, does this belong to. 195 falls between 194 and 254. So it's network 4 that we're interested in. Therefore, our network ID for a /26 CIDR application here is 165.210.0.192/26. That's our network ID. The gateway is 193 and the broadcast is 255. This concludes our review of how to use the Excel templates for CIDR to determine CIDR values when we're subnetting, when we're segmenting our network. If you have any questions, be sure while you're working the solution to practice using your templates, and that will help. That's all for now. Take care.